Hi, Wildcats. Today in class we did some practice problems related to series circuits. We looked at what happens and how we solve for the different parts of a series system when we have two or more loads or resistors wired in series. So we did this problem in class today. Just thought it would be helpful to maybe put it on video so you could watch it again at your own pace if you need to. They tell us a series combination of two resistors of 7.25 ohms and 4.03 ohms is connected to a 9-volt battery. And then they ask us some questions. So my table's already set up. We need to draw our circuit. So I'll do that. Here's my battery. It is 9 volts. It is connected to a couple of resistors, just one path, right? That is the characteristic of a series circuit, is that there's only one path for the electrons to take. So we'll just call this R1 and call this R2. They don't tell us in our problem if one is R1, what order they're wired in, and frankly, it doesn't matter. So we can pick, we'll call this R1 and this R2, so our second resistor. So then we would label this 7.25 ohms and this 4.03 ohms. Okay, so here is my circuit. They ask me what is the equivalent resistance of the circuit. They ask me what is the current and what is the potential difference across each resistor. So let's make sure we know what these means. Equivalent resistance, really, we learned in class, and it's in our notes, REQ is equivalent resistance, but and then there's a fancy way to say the total resistance, right? So the total resistance, they're looking for what is in this box right here. This is REQ. The current in the circuit, so that's this box right here. This is I total, the total current. And so we're looking for the current in the circuit. If we stop and think about it in our notes, we remember that in a series circuit, current is equal everywhere in that circuit. So whatever I total is, it'll be the same in all of these boxes. Or I can find any one of these boxes and I have all of these boxes. And then finally, what is the potential difference? And voltage is potential difference. So really what they're saying is, well, a fancy way to say what is the voltage at each resistor. So they're looking for V1, V2, and not V total. So let's start by thinking about what we know or what is given. So if I look at my picture, I know the total voltage in this circuit is 9 volts because that's what the battery is. So I already have this box filled in, 9 volts. I'm also given the resistor values or the values of each of these resistors. So R1 right here is 7.25 ohms. And R2 is 4.03 ohms. So now what we have to figure out is what is the total, and we need to think about what kind of circuit we're working with. Since this is a series circuit, that means that equivalent resistance is just found by adding them all up because any electrons traveling through here would go through this resistor here and then through this resistor. So they would experience all of the resistances. So we can just add them up. So 7.25 plus 4.03 gives me, oh, I put in a decimal wrong, 7.25 plus 4.03 gives me a total resistance or equivalent resistance of 11.28 is what my calculator says, but we'll go 3 sig figs, so 11.3 ohms. Okay, so now we learned today or practiced today that if I have two of these three boxes, I can use Ohm's law, V equals I times R, voltage equals current times resistance, to find the third box. So I have V now, I have V, and I have R in this column, so I can use that to solve for I. V, we'll say total is equal to I total times R EQ or R total. Since we're looking for I, we divide both sides by R, and the I total will be equal to V over R, V total over R total, or in other words, 9 volts divided by 11.3 ohms. Okay, so if I put that in my calculator, 9 divided by 11.3, I end up with 0.796. Yep, 0.796, and this is current, so it is amps. And just get rid of that since we know this is I total now. Put this over here, so amps. Okay, we saw that we learned that current is the same because this is only one path. So therefore, whatever the current is here, it's the same here and here and here and here and here, everywhere in a series circuit. So if the total current is 0.796 amps, then this must be 0.796 amps, and this must be 0.796. Okay, so now we have the current all the way across. So we found the current, check. We found the equivalent resistance, check. It is 11.3. And then they ask us for the potential difference or voltage at each resistor. So we're looking for R1 voltage at resistor 1 and voltage at resistor 2. Again, we can use Ohm's law. Voltage is just equal to current times resistance. So we can do V1 is equal to I1, although it's the same everywhere, times R1. We have I1 now, and we have R1 here and here. So I can just take those and do 0.796 times 7.25, and I end up with 5.78. And this is voltage, so this would be volts. I can do the same thing here, 0.796 times 4.03, the resistance for 2, and I end up with, or the value of resistor 2, and I end up with 3.21 volts. Okay, so now we have answered potential difference. So these charts are helpful in terms of kind of organizing the information that we're given right in the problem and then using it because we're kind of using Ohm's law to play fill in the gaps. We do have to make sure that we know the concepts behind this. Like the only way we could solve for V1 and V2 is we needed to recall that we learned current is the same all over the place. The only reason we could find our total is because we remembered or recalled that in series circuit, these just add together to determine the total resistance. So I hope this helps as you kind of practice your series circuit problems.